So we are live now.
Okay. So very good morning, everybody. So this is day 2 for the current trends in cyber physical system workshop. And today first speaker is Susmita Ghosh, and she will talk about entrepreneurship in CPS as an occupation. So let me introduce her. She is currently the director of the social techno-start-up DiagnoRite Innovative Healthcare. She is also a consultant with the BITS Pilani BioNest. She completed her postdoctoral fellowship from Harvard Medical School and her PhD from University of Connecticut. She has received numerous grants and was nominated in the top 50 of the India Innovates Growth Program. Her research activities includes healthcare product development, like developing high-tech, sensitive, and reliable blood test in affordable price, developing a novel molecular diagnostic platform for quick and reliable detection of drug resistance. So, uh, Susmita Ghosh, please welcome and start. Thank you.
A very good morning to everyone. It is a pleasure to be a speaker in this coveted conference, and myself as an entrepreneur will be happy to give my first-hand experience how to become an entrepreneur, because nowadays for young students, there is a culture. Can everyone see my slide? Somehow the presentation mode is not okay. Okay. So currently, a lot of people are encouraged to become entrepreneur, and young students, they think startup culture is very, very exciting, very, very romantic. It's a new romantic thing. Why? Because there is a high potential of rapid growth, and the work is usually internet based. I have something to say, but I will tell it later. And you have a close knit team. There is no code, no expression code. Means you can use any language. You can express your thoughts. You can deny it, and you are allowed to raise your voices at any time. There is no 9-to-5 job, and you are always surrounded by passionate people who take out the best thing out of you. And this milieu allows a fountain of innovative ideas, and you are building something entirely from scratch, and you own the startup when you make it from the scratch. As I told you, I have something to say about this. This is the idea everyone has about startup culture, but not everything is exactly like this. As first of the place where I will like to oppose is, people have the idea that startup is usually internet based and it can rapidly grow. So that actually hampers entrepreneurship in the bio field. And everyone thinks that even human are made of bytes and pixels, but no, there people have to rethink that yes, humans are made of blood and flesh, and of course saliva, because in the new corona days everybody is scared about the saliva and all those things. So human and nature is made of not bytes, they are made of something else. And startup culture, people who fund and people who work have to think how to also work on that. and there won't be any rapid growth. Okay. And also, need like an extended adda, even non-ending adda, but yes, no 9 to 5 work, but you have to work almost 24/7. There is no break. There is integral part of the startup is invention and innovation. And we are familiar with the two terms, but I think I have to define them and also make the difference of invention and innovation. And inventor discovers new methods or techniques. The new method can be anything. It can be useful. It cannot be useful. And always in the old movies, you have seen the inventors made so many things, and they are like a kind of bizarre. They make the inventor look like some odd madman. Yes, inventors are usually kind of mad, but innovators apply some of the inventions which has commercial purpose. So they want to monetize it. They want to bring those inventions for common man's or other people's or specialized people's use, and they make money out of it. Yes, entrepreneurs themselves can also innovate if they have that insight. What kind of insight? That yes, these invention can have insight into the society's need and how it can fulfill them with this innovation. The inventor who has become an innovator is nowadays called a technopreneur, an entrepreneur with a technology. And why more and more inventors are turning to become innovators? Because technopreneurs want monetary and other controls on their inventions. Otherwise, if their invention is monetized by somebody else, they usually do not get anything, and sometimes even not win the respect and the credit for the invention. Proudly give of two almost story Bengal Chemicals Limited. Bengal Chemicals and Pharmaceuticals Limited was the first Swadish startup in India. If you go back to the British ruled Indian history, you know British captured everything. They destroyed Indian economy, destroyed Indian local industry, clothing, garments industry, everything, saw industry. In those days, in early 1900s, early 1900s,
Hello, I'm sorry to interrupt, ma'am. Ma'am, can you please switch off your video? I think there are some bandwidth issues, and
okay.
it would be better if your video is turned off so that we can listen to you clearly.
Okay. Okay. So you can see the screen, right?
Not right now, ma'am.
Shall I have to share screen again?
Yes, ma'am.
How do I go back? Okay. Yes. I was telling the true Atmanirbharta story about Bengal Chemicals and Pharmaceuticals Limited. Can you listen?
Yeah, we can listen.
Hello? Okay,
Uh,
okay. So,
Ma'am, your screen isn't visible yet.
yes,
Yeah,
Yeah,
now it is. Now it is. Now we can.
okay, okay. So, in the British days, British captured India and destroyed Indian industries, the garment industry, the salt industry, everything. And they made Indians to depend upon everything for British. Clothes used to come from Manchester, salt used from England, and Gandhiji first made salt on the Dandi. You all know that. In those days, early 1900, the first 2 decades, Acharya Prafulla Chandra Rai and 9 of his friends, they were all renowned scientists, academicians, doctors. These friends together put some money and they created this Bengal chemical. And why I am very proud of this, because my own grandfather was one of these 10. And then Bengal Chemical became a real thriving industry. It was very successful and profitable for many, many decades. And they were the first. Can everyone hear me? There was some internet issue. Hello?
Yes, ma'am, we can hear you. Yes.
Yeah.
now it is fine.
And also they used to make personal care products. And for many, many decades until the late 80s, it was very profitable. Then government took over. Now Bengal Chemical isn't making that well, but still it is part of the Indian startup history. So how startups in CPS? I can't even say how many startups in CPS because there are so many of them. And the majority of startups come in defense sector and they provide cyber, physical and security and safety issues. And they provide service to schools, stadium streets, tampering and anti-tampering, anti-counterfeiting, even counter-terrorism. And a lot of big companies, big industries actually nurture a lot of startups to provide the small apps, provide the small services, and they put the entire things together. In healthcare also, there are startups. There are people in diagnostics, in telemedicine, in healthcare management, assisted rehabilitation, and there are more to come because nowadays the apps that will tell whether you have corona or not, whether there is beds available for a new corona patient or suspected patient, and what kind of infrastructure which will be requiring, whether they will be put to ICU, whether they will be put under oxygen support, or they can be kept in ordinary bed but isolated. Everything is now determined by CPS. And CPS is going to bring a sea change in industrial production. Now, design, quality, assurance, productivity, logistics, customer service, and even environmental issues are all gradually taken care of by CPS. And it's now one cloud-based platform that can integrate everything from starting to the customer or users place. Everything can be controlled by CPS, and there are many startups who are contributing in this unification. And that's why since startups and entrepreneurship is enriching the industrial environment in such a novel and better way, that entrepreneurship development programs have started everywhere. There are incubators associated with each and every, almost each and every branded or large academic institutions, and they help at nurturing the entrepreneurship. The stages of entrepreneurship, as one can visualize, is first someone has to have a good idea. They have to ideate, and from that idea they want to make the idea proven. This is called the proof of concept. From the proof of concept, they make a prototype, a minimal viable product, or MVP, which has to be validated in small scale or a pilot validation. With the pilot validation data and all, when they want to scale, they have to write a business plan. They have to approach investors and other funds, so that the investors know, okay, this is the prospect in the bigger picture. These are the customers who can be benefited. These are the customers who are willing to buy. And we can also make people converted into this kind of customers. So when this happens, when the scaling is properly done and customers accept the products or the services, then the company can either, the startup can either grow into an industry, or it can be acquired by a larger industry. And this is a standard growth process. And what is the role of the incubator? The role of the incubator is, when someone aspiring entrepreneur comes, they listen to the idea and they help them, mentor them to do the make the proof of concept successful, make the prototyping successful, even help in validation. But the biggest support an incubator should be giving is the networking, because otherwise entrepreneurs come usually like one or two friends, maybe 5, 6 friends together. Friends means professional friends, or they are good friends, best friends from beginning. But this is still very small strength. So these incubators open them to a huge network of investors, other experts in the field, who can not only strengthen the ideas, but also strengthen in their monetary supports by helping them raising the funds, helping them writing the business plan, helping them how to pitch properly. And since they have the pool of funds and they have the access to pools of funds and investors, this is how they help an entrepreneur grow from a budding startup to a large startup, or an entire industry, or help them being acquired. But I would like to say, as a entrepreneur who has burnt her finger in first hand, that entrepreneurship, whatever rosy and romantic picture it is, entrepreneurship cannot be taught. Entrepreneurship can be nurtured. The steps I showed, you can mentor one, but entrepreneurship should come from one's within. Entrepreneurship is not a substitute for a salaried job. You have to have the bug within yourself, otherwise you cannot be an entrepreneur. When you are an entrepreneur, the regular mundane routine 9-to-5 job will bore you. The regular salaried job and the kitch of your bosses and all, that will bore you. But even more, I think, yes, everyone gets bored with 9 to 5 and mundane things, but still people have to have that strength and courage. Okay, I do not need that salaried protection. I can be okay if I come out of this comfort zone, come out of the cocoon of uh, salaried job. And all the time people show that startup people have this much of money, but even if they have money, a true entrepreneur never goes for luxurious, right? Rather they keep the money, if they have money, for their further growth, and they trade luxury for the joy of entrepreneurship. They should be ready for struggle and multitasking. And there is a common term used in among entrepreneurs that one has to be a chairman to chaprasi. You cannot expect that I can hire a person who will do this mundane job because I don't like this, but it's your baby. So if you are hiring someone, this is not their baby. They're just a salaried employee. So they are not emotionally connected to that. And again, once again, I would say that if you have savings, rather stash it away for emergency capital. Accepting investment from somebody else is not always a good idea. I will give some more tips to become an entrepreneur. Usually, a small group of friends or like-minded people with at least some complementary skills should come together to form an entrepreneur group. Otherwise, entrepreneurship is very lonely journey. Uh, a, a lot of people say that they are sole entrepreneurs, but those are usually in, say, like a fashion designer or a restaurator. These people can be like sole entrepreneurs, but for technology field, you need some complementary skills, because in technology, you are always inventing and you have to have access to knowledge. So if you are thinking always in the term of technology, you may not be able to think about the business. And also technology also have different parts, different domains. So if friends can compensate each other with those domains, that will be the ideal and best startup. And each of them must have great tuning to each other and much trust. There is one thing, trust. Otherwise, you cannot succeed. There's a lot of time people think, oh, this is my idea. If I tell it to this person, he or she might steal it. If that is the situation, then don't go for it. You have to trust your partners that this is my idea, this is the way I'm going to do. Otherwise, you can never succeed. Otherwise, you will become competitors of each other. So this is not the way to become an entrepreneur. And there will be frustration. So each one should be holding hand to each other. Otherwise, the loneliness will frustrate you. And because entrepreneurship is like a addiction, you constantly think 24/7, and if things do not go in your way, you are bound to have frustration. So and you may fall into depression also. So to avoid that from the very beginning, you should have a team B, which are team B, a group of friends who are not your colleagues, who are not your partners, completely away from entrepreneurship, and you relax, you think something completely different from your startup and entrepreneurship experience, then only you will become a successful entrepreneur. If anybody has any question, I will be happy to answer.
Susmita says there's no questions. You can continue.
So I'm done with this. you can go ahead with your other presentations. Thank you very much for inviting to this conference once again, and a very good morning once again.
Okay, so Susmita, I see there's no question from Slack, but that stages of entrepreneurship, that I may ask something on that.
Okay.
Okay, so thing is that because we are academician,
Yeah.
right? And the stages, the first two stages suit us, like
Yeah.
idea to proof of concept, prototype development,
Yeah.
validation also we do,
Yeah.
but the second, third, and
Yeah.
fourth, that business plan development and fundraising, basically business plan, that we can't propose.
Yeah.
Or suppose group of students are
Yeah.
working, they are going for the degree,
Yeah.
but they are doing research
Yeah.
in a master level or bachelor level, and they have good concept, even they can validate.
Yeah.
Okay, but
Yeah.
the third and fourth stage, we don't find something suitable that we can go for that, because student have to degree, we are accommodation. So how to bridge that?
Yeah, that is the role of a good incubator to pitch in. You know, there are mushrooming incubators everywhere. Even BITS has a lot of, at least 3-4 incubators, but they are in very budding stage. A real hand-holding is needed in business plan development and fundraising. Because you know, of what I have seen, whenever I faced an investor, initial days, they used to say, oh, you are so passionate. Later on, I found that is not a compliment. That is actually a sweet way of telling that no, you do not make us listen to the sound of the jingles of money. So, because I am a consulted scientist, a technologist, I talk more about my technology, and I cannot say much about how to generate money, although I can write a business plan, but still it's not that effective. The products might be very good, the products may help a lot of people. Even if I can show the projections of the money, like how if a company grows, if the initial stage, if those many customers buy my product, and at the end those many customers will be, it's like 100-fold, 1,000-fold, lakh-fold. Still academicians or part-time academicians like us are not good people to pitch in front of investors. So a good incubator should make matchmaking. So it's like they can bring in a co-founder who is good in business and who will not meddle with the technology development part. And I have been proposing that to BITS platform, that why don't you bring in alumni and others who are already successful in making business. They understand business, they know how to make money, they have connections to high net worth individuals, HNI, who can also invest, and some of them have already turned to investors. So a good incubator platform actually makes the matchmaking as well. So if there is a problem is business plan, problem means sometimes, you know, even I was told that my projects are very good, just it has to be presented in a glitzy package. But still, this is one unfortunate part. Still, I haven't have a good partner who can present my projects in a glitzy package in front of the investors. People even told that you don't speak in front of investors because you are so much attached to the and passionate about your project. It sometimes dilutes. So this kind of matchmaking is required. The successful incubators I have seen in biofield, there is one in Bangalore Biocluster, the C Camp incubator, the NCL Venture Center incubator. they constantly are doing this kind of matchmaking. So they invite investors. The investors also, some of them do kind of mentoring, and if they find out potential in some of the projects, they immediately pick those. So this kind of help, this should be there in incubator. Otherwise, a lot of good technologies. There is plethora of technical ideas, new ideas among Indians. Indians do not lack talent, but just to bring them to the market, you need proper business partners, and the incubators have to play that proper role.
Yeah. So thank you, Susmita, once again. Soumyadip, you have any questions? Soumyadip.
So there is a question which I had. I've also posted it on Slack.
Okay,
So,
so
ma'am, if someone doesn't have contact with any incubators, but has like has an idea which is like in the nascent stages and does not know how to go ahead with it, because often these ideas which you have as a like for a startup or something, they are in fields very different from yours. So you do not know how to go about it, and but you still cannot contact an incubator as well at the same time because it is very nascent, and an incubator will only pick up ideas which are like a little more developed, and you have some sort of a business plan or something more to show.
Yeah,
So
actually, I understand what you meant. There are two things. One is readily available, but there's like there are hackathons, which are competitions where you can pitch your idea, and even very nascent ideas are sometimes encouraged. Second is what you said is very correct, and I have been fighting against that. I have been telling that you cannot always expect projects at technology readiness level 4 or beyond, because especially for biofield, reaching from technology readiness level 1, which is idea, to technology readiness level 4, which is like a minimal viable product or something, takes a long time, takes a lot of money, and also hand holding. So the incubators should also help with seed money and connect with people, give infrastructure so that the path is shortened. Less money is required for the inventor or innovator. Uh, so this is the solution. And actually, I feel that people who are making policies, like they are telling that entrepreneurship has to be encouraged, but they are not having any idea. They are thinking that entrepreneurship is Aladdin's genie. You scratch the lamp and then the genie will appear, and then it will make from the idea to market. No, it does not happen like that. There is toil and money involved in each and every step. So people have to work, the incubators have to work hand in hand in each step. It's not like the incubator will give you an infrastructure, means just an office or sometimes a lab, and then their role is done. No, the incubator has, if they think have to think in like long term progress of a project, or have to make India Atmanirbhar, then they have to handhold in each and every step. So, and that education has to be pushed, because even in BITS, I have spoken to all the incubator leaders. They are no, students or aspiring entrepreneurs should come up with their own idea, and they think idea means, as just you said, that it will have some minimal viable product. Then they will say, okay, I will connect you to some high net worth individuals. This is not the way India can become Atmanirbhar once again. From idea, there can be a groundbreaking idea, an out of the box idea, and from that stage onwards, everyone has to be nurtured. Yes, there are crazy ideas also which can never be successful, but there are ideas which have the potential to become successful. So from TRL1, people, aspiring entrepreneurs has to be nurtured. And actually, when it happens to the students, the teachers and at least the organization should direct them towards their incubators, and the people who will run the incubators, they should have a dedicated work at the incubator, because most of the places the incubators are run by part-time people, means they have a like full-time job as an academician, they have like 40 classes a week, or 40, not 40, say 9, 10 classes a week. So they do not think it has a priority. So only when there are dedicated people who will run the incubator, that, okay, I will go through the projects, I will connect with those people. So hand holding at each and every step, only then then our country can have more and more successful entrepreneurs and more successful products and processes which can make our country true Atmanirbhar. Because otherwise what is happening, people see that there is funds involved, but then because of this technology readiness level and all those things, people tend to do shortcut and not in the ethical way. Sometimes they buy a lot of things from China and then just change the look and then say that, okay, this is my invention. And that is actually happening in more than 90% of the cases, where there are tangible products there. Even for software, I have heard the Geo has made something substitute for Zoom, and they have used many of the source code and user interface, all those things. Why that is happening? That is not to be encouraged, but rather people have to be encouraged to, from the scratch, to develop some totally out of the box idea and not somebody else's copy. Does that answer your question? Hello?
Yes, ma'am. Thank you so much for that. Ma'am, I have a follow-up question to that. So,
Yeah.
so what I gathered from your answer is that the college incubator programs, they can play an especially important role in such cases because they are more connected
if they are effective. But most of the places they are not, because the people who are given the responsibility do not even know what an incubator is supposed to do. The college has made the incubator just because there is a push from the government that make incubator, or this organization has an incubator, so I have to also have an incubator. So there isn't a clear-cut vision in that.
So, ma'am, can you tell us a little more about the incubator at BITS currently and its activities and what we are doing there? Because ma'am, I have some friends who have ideas, but they don't know how to go about it exactly.
Actually, we can come offline, and I will try to push in my own way, because as I told you, the incubators over here, they are run by people who are not entrepreneurs. So they don't know the pain, they don't know how to go about this. So, but I am trying to fight for the cause of the entrepreneurs. That entrepreneurs need more support. So if you connect to me offline, I will try to push your ideas through the various incubators in BITS platform. Okay.
Thank you so much, ma'am.
And also I have access to incubators at IIMA because I was one of the top 15 India Innovates Growth Program. So I was sent to a boot camp there. So I have some access. If BITS do not agree, then we can access there. But you do connect to me offline. Okay.
Yes, ma'am. Thank you. That's great. Thank you so much.
Any more questions?
No, Susmita, I don't see any more questions. Thank you for a nice talk. That which encourage. Actually, it will encourage to how to get the funds and have a startup.
Yeah, actually, I would uh, request each and every one of you to push for the change in vision in this incubator policies, because most of the people who are running the incubators, as I already told, they didn't burn their fingers. So they have a salaried job, and
Yeah.
with that chair, they dictate what should be the rules. This is not the way an incubator can
Yeah, you are very
nurture
correct.
entrepreneurs.
You
So
are
you
very
all
correct.
have to raise your voice. My own, my sole voice is not enough. Okay.
Yeah, I understand. You're very correct because see, I have idea and I give to student, they get the PhD degree. Okay,
Yeah.
but I may not involve in this business plan and all the things. I say that you go and forward, find out how to do. But once they
Yeah.
get PhD degree, they out. Okay,
Yeah.
so
This is a common picture.
yeah,
What you told is very true.
mhm,
So there should be a permanent solution to this. That this idea should not be discontinued. There should be continuous process. That
yes,
okay, this idea has a potential, so it should see the light of the market. And there the incubators should have a role, and the incubators have to change the vision, and the faculties who want this, they should raise their voice.
yeah. So
The
that
policies should be changed. The funds which are coming, they should be channelized more towards the incubators in the proper way. It's not like I will just make some competitions, and most of the money in the competitions go in inviting people. Nowadays, it's better that all the platforms are becoming online. Otherwise, their hospitality, hotel, and all those gala dinner, this and that, that used to exhaust most of the funds. Okay,
yeah,
but
that's what that
the seed funds, which is different from the academic research funds, are to be needed. You sometimes need dedicated technicians or technologists to complete your products, who are different from your students, because your students have some like fixed goal, that they have to get those many papers, they have to get the PhD degree, and after that goal is achieved, as you said, they forget. Okay, so
yeah,
you have to have some dedicated people to work on the projects as well, who will keep the continuity.
yes,
The
that's that's
students
that's
may
what
have,
missing.
yeah,
That's what's missing actually in the
yeah,
academician.
your students may have great ideas, but
Mm,
they do not always have the time or priority to work on these projects, because that time they feel that no, I will miss my grade,
yeah,
I will not get that prize, I have to get the internship in that company. If I work in the project, I might miss it. See, the priorities always change.
yeah,
So, and as I mentioned, that the entrepreneurship should be a bug. People will feel, no, this is my thing, I will do it at any cost. That kind of bug is rare, and those who have it should be nurtured.
you
You,
should.
Uh, I have
yes,
one question.
Yes,
yeah,
ask.
I just asked, that is, yeah, it's a wonderful talk, ma'am. So one thing is that the last 2 years ago, uh, we read one articles that is from the Delhi IT Senate. They issues that if the students successfully build an incubator, a startup, so that is equivalent to any type of thesis, that is a PhD degree, uh, that is equivalent to the PhD degree. So when I talk to this scenario with some professors, so some professor is very conservative, but some of them are very encouraging. For examples, so professor which comes from the abroad and settled to the India, they are very encouraging to promote the entrepreneurships, rather than those who are the old-minded people. So they are not very enthusiastic to build such a entrepreneurship. So What's your viewpoint, ma'am?
Yeah, what you said is absolutely correct. Building a startup or building something tangible which is marketable should always be encouraged, and those who are conservative about it, we have to put their voices down by making our voices up.
Yeah, that's true.
So I think we should once again thank to Susmita for a nice talk, which is very encouraging. And I think we may take some role to bridge that gap that what academician
Yeah,
and
why
business.
don't we connect offline so that
Yeah, I will write
my
a mail to
voice is
you.
also strengthened.
Okay, I will send.
My voice is strengthened, right?
Okay. Okay, thank you, Susmita.
Okay. Right.
Rakshit,
Yes, sir. So I think
next.
we can wait for 10 minutes.
Yeah, here in the campus, power is not there.
Oh,
So be careful. See, when I came, I have put the setup in desktop, then immediately I have to switch to this mobile
oh,
and tablets.
okay.
So that's problem was there. So I was trying to set up how to do that then. So power is not there. When it will come, I don't know. So, but I think in tablet it will work 2 hours, 3 hours more.
Yes, sir.
Okay,
That
so
should be
that is there. I have a backup on the tablet. Okay, so we have to wait. What's the time?
So it's 10:51 right now.
So 10 minutes is there
Yes, sir. We'll just
because
wait for Vinayak sir to connect
yeah,
with us.
yeah. So
Then we
10
can.
minutes is there. See, let me see. I don't see how my video is coming. Can you see me?
Not right now. Now it is coming, sir. Yes.
Okay, so that time I don't know. I was trying to do that because that time just means the Android tablet.
Oh,
I set up everything in desktop because I prefer desktop, but just switching to this, I struggle a little bit. Now it is fine,
yes,
I
sir.
think.
Yes, sir. Yes, sir.
Okay,
That's good, sir.
okay. Thank you.
So, did you attend any of the sessions yesterday? Did you see any of them?
Offline, I have listened some talks, not online. I was there.
Oh,
It's,
okay.
into the inaugural session, I was there.
Uh,
Inaugural session, I was there. After that, I have some other necessary work, so I went to the PhD student and discuss all the things. But offline, I have seen some talks, not fully, but critical things.
Yeah, our next speaker is Professor Vinayak Naik. So he will join soon. I think you said 2 hours. It will be.
I have set up this desktop.
Hi, Vinayak sir. Can we please test your mic and presentation if there is any? Good morning, sir.
Hi, Vinayak. Good morning.
So can we start the next?
Vinayak sir has just joined.
Okay. What's the time?
Share screen.
Oh, 10:59.
Can you see my screen?
Yes, sir.
Can you make it full screen?
Yes, I will.
Rakshit, are you going to live?
Rakshit.
Yes, sir. Yes, sir. We can begin, sir.
Okay. So I will start. So our day 2 second speaker is Professor Vinayak Naik, and he will talk about the machine learning for CPS. and basically on smart transportation for smart
Geo?
cities.
Geo needs poor connection.
Smart
Okay.
cities.
Yeah.
So I may introduce the Professor Vinayak. He's a professor of computer science with the Opera Awards in BITS Pilani at Goa campus since 2018. He heads the Computer Science Department and Computing Center at the Goa campus. He is a member of the faculty at AppCare at BITS Pilani, Goa campus. He is a funding member of BITS Goa Innovation, Incubation and Entrepreneurship Society and adjunct professor at IIT Delhi, a member of the committee to evaluate ICT requirement for census 2021 formed by the Ministry of Home Affairs, a member of the governing council of IIPHG Nidhi Incubator for Public Health, a special advisor to macro health education, and a chief architect at Backpack. He is a founding member of the ACM SIG Mobile Chapter of India. So, Professor Vinayak, very welcome, and it will be good to see you in ML for CPS, which will be encouraging for the student. Very welcome.
Thank you. Thank you, Sanjay, for the introduction, and thank you for inviting me for the talk, Soumyadeep and Rakshit. Is the screen visible? As a mandatory thing, I'm checking audio and screen. Everything fine? Then I can begin.
Yeah.
Great. Okay. So the topic of the talk is smart transportation for smart cities. We've started saying the word smart everywhere now. We have smart wearables, smart microphones, smart TV, and many other equipment with smart. Once we get an ecosystem of these smart equipments and devices all around us, that can be leveraged. All those plethora of devices, smart devices, can be leveraged to bring smartness into how we move around in this. Okay, and that's where the direction of the talk is, and it leverages a lot of cyber physical systems because to get a pulse of how the city is moving, where people are going, where there is a rush or where there is a opportunity of there's much rush and there opportunity to route your traffic through those places. So for all this, we need sensors, and with the GPS locations getting almost everywhere because of the smartphones, it gives us a platform now to think about how we can make the commute less taxing for people. Or if the people are interested in their health, by health I mean not to inhale a lot of air pollution, or to exercise more and go to places where they can move around. So in that side also, the smart transportation will, use of the cyber physical systems for the smart transportation helps. This is a joint work with two of the students who have graduated now from IIT Delhi, Megha and Anchal, and with an old colleague of mine, Venkat Gunturi, who is now at IIT Ropar. So let me say how we are going. And we already have smartphones which tells us the routes that we have to take through Google Maps. Then we see which is public transportation available. Now we also have taxis or cabs which we can book through different sort of mobile applications, because the taxis also come inbuilt with the location sensor. So for example, Uber and Ola in India, that's continuously giving us a pulse of where the demand of the taxis are and where it is congested. So now we have the global navigation system, which is the GPS, the wireless communication, and coupled with a lot of data getting streamed from all these devices, which means the mobile phones and the taxis and the buses and trains, all right, giving us a real-time stream of the pulse, and it will help us. If we leverage this data smartly, it can tell us where the road constructions are going, where the accidents are happening, where the parking is available, what sort of route I should take so that I can quickly reach my destination. So the senses, the stream of the data, and then coupled with the machine learning, which I'm going to talk about today, or the artificial intelligence, AI, will overall help us, help people also as a community, and help the governments also to plan the next cities, or what sort of are the choke points or the bottlenecks in a city, which will need help. So smartphone mobility is fueling this wave of future transportation. So going back, let's go back in and understand where we started from. So once your smartphone or person had, the application sort of
Professor Vinayak,
started with is the Google Maps. Yes.
Professor, his voice is breaking.
Yes.
So I think you can switch off the video so that bandwidth problem will be not there.
Okay.
But slide went out. You have to again share the screen. Professor Vinayak, again you have to share the screen, I think.
So Professor Vinay just got disconnected. Yeah.
Okay.
Yeah, I'm back. Let me stop the video.
Yeah.
Okay, now hopefully this should resolve the issue.
Yeah.
Are you still able to see the screen?
Yeah, I see the screen, your screen, but not the slide.
1 minute.
Yeah, now screen came. Slide
Okay.
is visible. Just make a full
And
screen.
you
That's
can
nice.
hear me also. Yeah,
That's
full
nice.
screen.
That's nice. You can start.
Okay, so let's so we were at the point where we sort of went back in time in 2004, where Google Maps is sort of the first application that started giving us information people are moving in cities. And at that point, it was very easy to map or geolocate people in the developed is because the roads are well documented in digital maps. But for a country like India, which did not have this database of maps of the roads and cities digitized, it was very difficult. So we had our first challenge to solve in the direction of smart. So a person who was looking at Google Maps, Lalitesh at Google, right? What he came up with the idea is, instead of depending on the existing databases and what records we already have, he thought, let's leverage the population of India. Let's leverage that the smartness people already have in making these maps richer and latest and up to date and digitize. So he developed a tool in the Google Maps. It was called Map Maker, which everybody in India had. And using this tool, people can give inputs about where the roads are, what sort of road will lead us to where the shops are, where the taxi stops, where are the bus stops. So he could bootstrap this information for India Google Maps very quickly. Otherwise, it would have costed us a lot of time and money to collect this data. So the idea that we want to bring forth is, we can leverage these smartphones that every people is carrying to give us data, instead of installing the sensors on the roads or installing the cameras on the roads or driving vehicles with the cameras. Let's use the existing infrastructure. Let's use what we say participatory sensing. People are carrying devices and sensors with them, or a person itself, himself or herself, becomes a sensor and gives us the data. So that's the idea. Now, let's take an example of Android phone, but this is also applies for iOS or other ecosystems of smartphones. So Android predominantly use three technologies and the other smartphones: GPS, cellular network, and Wi-Fi. GPS and cellular is an infrastructure based network. That means, right, somebody has deployed it and planned it. Wi-Fi is, it's sort of unplanned. As people start putting up their Wi-Fi access point, we start seeing the proliferation of Wi-Fi networks. But all these three things work or can be used on the principle of triangulation, where we know the location of the access points or the base station or the cell phone tower, or right, so where these are located, and we see what sort of range they cover around themselves. And when we can, so if you look at this point in between, at the intersection of the three circles, if you can hear these three cell phone towers, 1, 2, and 3, you can estimate that you are sitting at the intersection of these three circles, and that's your location. Same thing can be leveraged even for Wi-Fi access points, as is shown in the picture at the bottom. We have multiple access points. All of them will have their own range, like the cell phone tower or the GPS satellites, and the phone will pick it up. Now, all we need is fingerprints of these intersection points at multiple locations, so that later on, if somebody gives us data, we can provide them with the location. So as you see, this Wi-Fi based is also something which is in the same, using the same idea of sourcing data from people. And depending on the infrastructure, we source data from the people and give information to people again. So from the people, for the people. So this, now coming to today's state of Google Maps, right, we can see that live traffic. For example, if you are giving your destination, it will show you different paths that you can use to reach the destination, and each path will be also shown with where the bottlenecks are, where there could be an accident, how much delay on an average compared to the regular traffic on this road or usual traffic on the road, how much additionally. So now you can, as a person, make a better decision, better call about how to go about to reaching your destination. So we already have success point through Google Maps, and we have shown that this system scales to a lot of people. Even for a country like India, we can scale it up to that level. Now let's move forward. So we know on the roads how much is the traffic, but as you know, a lot of people travel using public transport. For example, the metro trains or the railway trains, the local trains. Now I'm showing you three pictures. So on the left, if you're sort of lucky, you're going on, let's say, a weekend or right early, very early in the morning, then you don't get that much of rush. But during the rush hour, you will typically see the station will look like something in the what we say unlucky, or right, maybe you go on a time where there was a problem on the rail network and sort of the rush builds up. But you can still manage. But then there are points in time where it just gets hazardous for you to travel on these railway trains and metro stations or metro trains. And this is right actual real photo of what happened in Mumbai, and a lot of people, in fact, because of the stampede, died. The question now for us is, what if on my phone I can see what is the current rush level, how much is the rush at different stations? If I want to take trains, beforehand I get a picture of or the idea of how much is the rush. Is it very crowded, right, or is it less crowded, or is it like dangerous right now? And that will help a lot of people, right? Especially the senior citizens and the younger people, the who want to travel through this. They can avoid these sort of times and go at a time when there is a less rush. Now, what is required to solve this problem? On the Google Maps, right, what they leverage is the smartphones and the sensors in the smartphones and how fast you are traveling on a road. Through the GPS, they understand that and tell you how much is the traffic. So if we assume almost every person in this train is carrying a smartphone in their pocket, then can we leverage the sensor, depend or use the data coming from these sensors to see how much is the rush, okay, at a station? Then we potentially have a solution that can tell us about congestion at train stations and bus depots and metro trains. and that will, right, give us a smarter way to travel. Now, we are not the first one who sort of looked at this problem. People have been thinking about this, and not in just their existing work, but if you want to tackle this question, the first thing that comes to your mind for data or sensors is your CCTVs. All of these places have got CCTVs, closed circuit TV cameras installed. If we can just look at the camera, we will get an idea how much is the rush, right? That's easy to do. Or the other way to look at other modality to get data is RFIDs. A lot of these metro trains, at least, if not the buses and the railways, but metro trains have RFID stations where you tap on this RFID, your RFID card to enter into, and that is how you pay also. So if we get access to one of these, we can understand how much is the rush. The first one being the more accurate, the second one may not be as accurate, but we can still utilize this information. But it comes with challenges. First thing is, so we talked to the Delhi Metro Corporation and the Metro Railway Corporations, and getting this data of CCTV directly, because we want it in real time, is very difficult. In fact, right, they are not willing to share it for the privacy reasons, to send this data directly to us. And old, so you can't really utilize old data also to build historical information. So non-availability data is the first thing. RFID also suffers. Right? These people have not plugged in their system so that RFID data can be directly exported in real time. The other thing is the privacy. I mean, camera also, once you start tracking the face of a person across the city, it's a privacy issue. Same with RFID. With RFID, I can know where that person is boarding the train, where he's getting off the train, where does he travel, he or she travels. So people may not be willing to get this data shared by the Metro Corporation to other systems. Or they will at least would like to have stricter control on the data. And not just for metro trains. So I was at IIT Bombay campus. I was on the IIT Bombay campus, and there are these buses which are sort of, we call shuttle students. And even for that, if you try to take a bus at the time of lunch hours, in a rush, right? So solving this problem at the level of metro and buses is, or the city-wide buses is one, but we also would like to take this solution and run on campuses without, so the cost, I mean, somebody at the Metro Corporation can bear the charges and can pay a lot, but somebody on a small locality may not have that much money. So the solution should be scaled down also with low cost and can be implementable there too. So let's now see what sensors we could use now that we don't have RFID, we don't have CCTV. The first couple of sensors that we will utilize to solve this question is accelerometer and barometer. Now, what's accelerometer? Accelerometer is a sensor that gives us acceleration. It does not give us the speed, right? So it's a second order acceleration. As you keep increasing the speed, it will tell you that you're just increasing the speed or decreasing the speed. But at this moment, what is your exact speed? That is not available from, I mean, you can do integration, but then you should know, and as you keep integrating, the error accumulates, and then you are off the actual value. Second sensor is barometer. Now, a lot of phones, accelerometer is there on every smartphone. The high-end smartphones do also come with a sensor called barometer, which is giving you the elevation. As you go high, it changes, and the sensor is sensitive enough to capture small changes in your elevation. So we will make use of both, and we will look at metro travel as a running case study to see this problem. Now, as a first level, right, we started this work long back, and we couldn't just directly to a point where we can tell how much is the rush. So what we decided as a first attempt or first step at the solution is to first see what is the person, the person who is commuting, what is he doing, he or she is doing at the metro station. Is he sort of standing at one place, or is that person is standing in a queue, right, which is very long? Because if the queue in which the person is standing is very long and taking a lot of time, that indicates that there is a rush. The other one is stationary. If the person sort of goes on to the station on the platform and is not able to board the train quickly, that also means the person, the train station, the station is crowded. So if we can find out how much time the person is spending being stationary or queuing, that is a proxy or an estimate of how much rush is there at the station. If the person, the other extreme of this is the person sort of walks through the metro station platform and immediately gets on the train, we can say with a very high probability there is no crowd, there is no rush at the metro station. We don't have a direct information of how many people are there at the metro station. That is, we don't know the density, but we have a proxy sensors which can, with very high probability, tell us how much is the rush. So now, once the first thing we have to identify whether that person is in the metro station or in the train. Okay. So once the person is in the train, that is not going to talk about that, right? So we'll only talk about when the person is at the metro station. So that is our first question to be solved. The second question that we have to solve is, once we know that the person is in the metro station, then what sort of activity that person is doing, whether that person is moving, standing, he's stationary, sort of not able to move much, or he's climbing up. Now, why climbing comes in the metro station? There are staircases to go from one level to another level. So that's why we want to find out whether that person is climbing up the stairs or climbing down the stairs. So overall, at the very high level, two classes to identify: within the train or in the metro station. Now, once the person is in the train, sort of we know that person has moved away. So we will focus or zoom on metro station class. And within that class, we have 4 subclasses, which we are calling moving, queuing, stationary, and climbing. Okay. Let's first look at our accelerometer data. So we took it and we are showing you on an XY axis. On X axis, we are putting out the time as the time moves from left to right. And on the Y axis, we are telling you the acceleration, the scalar value in terms of its magnitude. And if we look at this as the red curve, we see 4 different sort of patches in which we can divide our stream of acceleration. In the first, we see very high acceleration. That means the speed is changing all the time. And we see, and when we look at this or correlate this with the ground truth, because we know what the person was actually doing, we asked that person to keep a log or a journal of the activities. The person was not moving in the train. So that's one. Then once the person boards the trains and the train sort of moves smoothly, see, picks up the speed, the train tries to keep that speed constant. So that means the acceleration sort of stays constant. It becomes 0, in fact, not constant. The acceleration becomes 0, not constant. Right? So it comes down. Except for a couple of places where this point and this point, where the train comes to a station and sort of stops and then starts again. Between the 2 stations, then the acceleration is almost null. Now, when the person comes out of the station, again we see sort of this movement, and when the person boards the train moves. So we get a confidence that looking at the accelerometer readings, we have a chance or an opportunity to classify the data into two classes, within the train or on the metro station. Okay, so this is giving us that information. Now, when we started collecting data, we had to handle the class imbalance problem. What is class imbalance? While we were collecting a lot of data, the data where the person is in the train sort of was more than the amount of data we had for the case where the person was on the metro station. Okay, and it could be other way also for other people who are collecting the data. So if you have this issue, then we need to deal with the class imbalance problem. The second one here is studying the performance of different classifier. So we don't know at this moment which classifier will work out to be the best. So we will try out many classifiers, which are sort of the popular ones or the ones that people have been using to see which one performs the best. Now acceleration as one value we will show you that it can't be just used as a simple statistical thing. So we need a more elaborate way of representing the feature set, the data, so that we get all the information, the minute details of how acceleration is varying. Right? Now let me see, half an hour more. So as a related work, people have looked at this problem from a lot of different angles. Right? So if you first take the approach of statistical or data mining. So what data mining people, or what people who leverage the ideas or the techniques of data mining, what they have done is they look at the acceleration time series data and converted that acceleration into something which we say high acceleration, low acceleration. Right? So that is how they represent the acceleration values, and then what they get is all these values in terms of high and low labels. Now that as a character can be combined into words, and then we can use the techniques of data mining to find patterns in these documents. And some of these patterns can be called as on the train or in the train, or some of these other patterns will be then classified as in the metro station. Okay, so that's one technique to use. The other way to classify different approaches is what features are you using? Are you using time domain features or frequency domain features? The time domain means you just look at the amplitude of the acceleration, and then within a window of time period, you can calculate mean, variance, mode, and so on, all the statistical different order features. The other approach is you completely convert this into a frequency domain data set. Okay. And then on the frequency domain data set, once you do a Fourier transform, you can find out how much is the energy in different frequencies. Now that did not work out good for us, because all these activities and motions and physical activities people do did not come with a very dominant frequency. Right? It's not like one frequency, unlike the audio, where we have for a person certain frequencies, and we can classify the audio using frequency domain analysis. But the physical movements, especially on the train and on the metro station, did not come with a very strong correlation with frequency domain features. So we looked at time domain statistics of the data. Accelerometer is one sensor, but people have used magnetometer. What a magnetometer is a sensor that gives you how much is the magnetic field acting upon your sensor. Right? And why is this important? It's because the train is built with a lot of material, right? Metal, and that metal will have a signature. So for the problem of whether you are inside the train or outside the train on a station, right, it will have a big signature of how the matter around you is. But the two things, one thing is, again, a lot of phones don't come with magnetometers yet, and the second one is while you are in the metro station, right, there are trains going by all the time, so it's very difficult to understand or capture this signature. The other signatures are Wi-Fi, GPS. Both of sort of did not work for us for GPS because a lot of these stations are underground and the GPS signals don't reach there. Second one is India still don't have that much penetration of Wi-Fi access point on the station or on the station. So there is no clear signature about which access points you see on the station and which access point you will see inside the train. And once the train is moving fast, it's sort of also hard to get a good connectivity of Wi-Fi access points. So we couldn't use that. So we'll stick with accelerometer, we'll stick with barometer, and we will use statistical features in time domain. So that's how our solution is now panning out. For our, it's all experimental approach, empirical approach. That means we collected a good amount of data on the actual phones on real metro stations. So our sampling frequency was 50 Hertz. We also tried it at different other frequencies, but this worked out to be the best for us. And we collected ground truth. That means it was all label data. We utilized supervised learning. The labels where we asked the participant to tell us when they are entering and exiting the metro station. I mean, they don't have to really type these things because when they enter, like from their GPS location, we know they are entering the metro station. And same thing when they exit from the metro station, we again look at the GPS and we know that they are exiting the metro station. So all this data was automatically collected in the background service, automatically tagged and uploaded to a central server. The user is not burdened with continuously tagging manually on the phone. Overall, we got 23 hours of accelerometer reading across 7 volunteers on traveling on 9 different metro stations for their daily commute. So this is at that point the map of Delhi Metro. Now we've got more lines, but we covered the stations which are what we say junctions: Kashmiri Gate, Rajiv Chowk, and Central Secretariat, which are at the intersection, at the junction where there is more rush. And then we also covered stations which are at the periphery, where there is not much of rush. Okay, so these 4. So we got a balance of the popular stations or stations with more footfalls and stations with less footfalls. We ensure that they are traveling at different times of the day and different days of the week, so that all sorts of traffic patterns get covered. So acceleration, as we all know, is a vector with 3 dimensions, x, y, and z. So on a phone, it's your x-axis is right at the bottom, horizontal, y is vertical, and z is something that comes out of your phone. We converted into a scalar value, and we took we take the scalar value using the formula, which is well known. And then once we have this acceleration as one value, we looked at binning, which means we collected this time series data and create segments of size 20, 30, and 40 seconds, and then find out some features which we'll talk about in the next slides for every bin. Now, one good part about this acceleration being a scalar value is now it doesn't matter how phone is kept, in your pocket or in your purse or in your backpack. It could be in any orientation, or you could be holding your phone in your hands also and typing something or playing a game on it. That doesn't matter, because what we look at is just the acceleration is a one scalar value. So our solution now is, right, can work in any orientation of the phone. That's the good part of the solution. When we did the binning of the acceleration for different sizes of windows, we also looked at overlapping windows and non-overlapping windows. So non-overlapping, I think I have a slide. Yeah. So the non-overlapping window is something like this blue box at the bottom. So one window, then second window, and third window. There is no overlap between the blue windows. With the gray ways of windowing the data is like this, right? So now you about 50% overlap between 2 consecutive gray windows. So that gives us more windows, but it also gives us data that sort of, right, is redundant across multiple windows. Okay, so you might see the same value again and again, and you have your training algorithm should be able to this data coming again and again and should not detect it multiple times. The issue with the non-overlapping window is you could be unlucky in a way, so that every time a transition of the event happens, or one event itself will get broken into two different windows. Okay, one complete cycle of an event, let's say you're walking or stationary in one window, it might happen that it always gets broken into two different windows. So there are pros and cons of overlapping and non-overlapping, and the question is now which one really works for which classifier when we use empirical study. So yeah, so this is our iteration and this is in metro station. So the next point is which will be our features, what features will we use. If we look at this now, and the simple ones are, the first order ones are the mean and the median and so on. And if I am showing you two plots, one on the left is showing you the mean of two different classes in train and in station. If you see there, the mean values are not really separated. Right, so for one class, I'm representing it with the circles, and the second class gets represented by X. So you see, there is no clear separation. If you use mean, also there is overlap between the two classes. And if we look at the median on the right, also there is overlap. And we found out the same thing for mode. So it's not easy to just look at the mean and median of different windows, and that can give us a classification. So now that the first order thing did not work for us, we look at a more comprehensive way of representing this data. So cumulative distribution function, or CDF, as we all know, is a way of looking at the entire distribution of the data, not just the mean or the median or the standard deviation in between, but entire distribution, right? All sorts of probabilities, values, right, coming with different probabilities. So that's a more right, substantial or more comprehensive way of covering the entire distribution of the data set. Now, CDF works for continuous data. What we have is right, it's not continuous. We have data points, acceleration come in, right, in different levels. So what we do is we compute the empirical CDF. Okay, so if you see now, these blue, right, step function look like thing, this is sort of quantized or digitized way of looking at the CDF. Okay, when we plotted probabilities of all different values that we see in a window, right, we can see this blue line. Now what we do is we try to fit a smooth curve across, that is the empirical CDF. Okay, so blue line shows the eCDF, and then this curve that we fit gives us the CDF, empirically derived on top of the using eCDF. Now at this moment, we are not looking mean, mode, or variance, but we are looking at the CDF of the data. Now, very quickly, I will tell you all sorts of techniques we use in this particular work. I will not go into detail about what each of these techniques are, because now these are very popular. A lot of people already know about that. So we leverage, or we utilized support vector machines, SVMs, which is for classifying between two different classes. Okay. Then we use RLR for us in the paper, or what it stands for regularized logistic regression. Now, quick introduction of logistics. So regression is something that gives us a mathematical function which correlates to different variables. And then logistic is not linear. It goes on the logarithmic scale. So the two data can be related with each other on a logarithmic function. And this is regularized because we had the class imbalance problem. To handle that issue, or right, the issue of overfitting the data, to avoid that, right, and make this right curve not do overfitting, we do regularization. To avoid overfitting and analyze the importance of each features that we select. So SVM, regularized logistic regression. The third one is random decision forest. So this is a classifier which is trained on different bootstrap of data derived from the set. And this also inherently handles the issue of class imbalance because it is a bagging ensemble learning method. So it creates a data, bootstraps data using some less amount of data by creating many more data sets. And the other advantage of this is it has a lot of decision trees built inside it. And then overall, the decision of the classifier is sort of done using the voting across different decision trees. Okay. So this is more robust as compared to the first two ones. To again quickly tell you the class imbalance effect, because we had data for one class more in amount than compared to the other two. So for example, in particular, we observed that in metro station class constitutes only about 25 to 30% of the entire data. A lot of time our participants actually happen to spend within the train because they're traveling long distances. So we could handle this using the decision forest. For a case of SVM, which is not coming in inbuilt with the ensemble method, what we had to employ is we use a differential error cost on top of the vanilla SVM. Idea in simple words, what differential error cost is, there is a different amount of penalty given if you misclassify. Okay. So minority class and majority class, because of the class imbalance, there is one which becomes majority class and then one which is the minority class. So we have to penalize more if we make a mistake for the minority class. So there is more penalty given to that. So that deals with the problem of class imbalance for SVM. And then we also use the technique of ensemble learning that we understand from the random decision. Use modified SVM and logistic regression to utilize this technique, so that equal amount of data is given for both majority classes and minority classes. The idea is we partition the majority data set into multiple sub data sets, and then each of these sub data set gets combined with one minority subclass examples. And then this is sort of artificially generated data set using bootstrapping. And this overall then gives you the equal amount of data for both minority and majority classes. So now we've dealt with the issue of class imbalance completely. We've got multiple algorithms, SVM with differential error cost, and then SVM with ensemble learning. Then we have random decision forests in itself, and then regularized learning with in itself and with combined with the ensemble learning. So that is the entire spectrum of different techniques that can be tried on our data set. That's one x-axis. And then on the y-axis, we have using order statistics, which is the mean, standard deviation, mode, variance, so all those, median, sorry. And then the CDF, which is a more which is a deeper representation of data in terms of its distribution function. Okay, so this is our metrics of all combinations that are possible. And now let's see. So we used a robust way of evaluation, which is n-fold. N is 10 for us. So multiple data sets were created and they were tried, and this was done again multiple number of times, so that we've got statistical confidence in our results. We looked at the entire confusion method in this particular slides or our presentation. I will talk about predictive accuracy and true positive and true negative rate. But our paper contains entire confusion metrics for each of these. Now, what are our observations? We found that the impact of, first, let's say the impact of window size. When we change it from 20, 30, and 40, we found out, and we tried bigger also, but we learned that 20, 30, and 40 are sort of the good ones, and 40-second window size attains the best estimate of accuracy overall, and TPR and TNR. So that is sort of the amount of data one should look at a point, in one point, and do the ECDF of that. And this is robust to a lot of other mini activities. For example, person might be playing with the phone, typing on the phone, talking on the phone. So all those sort of activities, even those are going on, this is robust to capture your physical activity. Between the overlapping window and non-overlapping window, so we tried different percentage of overlaps, and we found out at the end is window with 10% overlap performs a little better for in metro station. Okay, for the class where you're on the metro station, a little overlap actually helped us. But when you are in the train, a non-overlapping is better than continuously getting any overlap. So if we don't care about this little benefit we found with the 10% overlap inside only station, as a broad method, you could just take non-overlapping windows, and that will give you almost the optimum result for both the classes. So this is showing you for 40 seconds what happened with order statistics and with ECDF. Okay, so for both of them, ECDF and order statistics, 40-second is the best, and non-overlapping is the best. 10 minutes. Now the second parameter we tried for two different values is order statistics, ECDF, and ECDF perform as we would expect, far better. In fact, the difference is we will show you later on, because that is giving you the entire distribution of the data, not just looking at a very minute mean or median, but it gives the entire CDF of the data. So it is a more robust statistical feature to capture your activities as compared to the central tendency of mean. So we see consistently better performance, except for maybe this one, SVM plus DC. That ECDF performs better, right? For here also, it's again, like for these two cases, SVM plus DC and regularized logistic regression and ensemble, except for these, ECDF works better. It involves a little more work. Now, for the ones that we really care about, which gives us high accuracy, that is the random decision forest and SVM with ensemble data sets, right? It performs far better. So ensemble learning methods in itself, because RDF in SVM also performs. So ensemble learning is a better way of handling the class imbalance problem when we employ it, and ECDF on top of that helps us to get us to a far higher value. So predictive accuracy almost reaches 99% if we employ that. Okay, so this is the entire summary slide. Now we talked about predictive accuracy. This one is talking about the true positive rate and true negative rates. And again, if you look at the ensemble here, right? This is where it stands, 98 and 99. So ECDF with ensemble performs very nicely on our data set. Okay, now in the interest of time, let me tell you a little bit. So this comparison, let me first say that it's not completely fair, because we've not had papers which are looking at the same data set and applying different techniques. Okay. There are a lot of a lot of work has been going on, but there is no standard benchmarking data set that's still available, at least at that point in time. So we looked at other papers which are looking at only train and metro station and train travel. And when we saw and using, of course, accelerometer as a sensor, what sort of accuracies they are getting, what sort of confusion metrics they are getting. So they didn't use the ECDF technique. So they look like maybe the first order statistics of the data and those features. And then the numbers that they saw are less compared to us. So I think we are going in the right direction. We are learning more about the nature of the data from the accelerometer and the issue of the cross imbalance problem, and we are improving upon. And we saw, for compared to two different problems or papers looking at similar data, our accuracies and precision record values are better. Okay. So now we got more chance of accurately classifying whether you are in the train or on the metro station. As a summary, our study and experiment have showed the following two things. Accelerometer data can be used to detect two different patterns in train and in metro station classes. Okay, so there is hope there, and the accuracies are good enough. This classification, right? We were confronted by the problem of class imbalance because of the way maybe our data collection strategy was handled. But we could leverage the ensemble learning methods that we already know, and that solve the problems. If you don't see the class imbalance problem, you're already at a better position and you might see still further better accuracy. And ECDF turns out to be a better way of representing the features instead of the central tendency in the data, mean and median, because it is more robust to the outliers, and it gives a general bound on the performance of the entire data set, not just at one value, central value in the data set. So I presented sort of the first problem. Now we were able to identify the in-train and in-metro station. Right? The second problem, again in itself, is what we look at within. So once you know you are on the metro station or you are on a platform, that has already given us an indication how much time you're spending on the platform, and that could give you estimate about how much is the rush on the train. But if you want to, right, again zoom inside this and find out how much is the queuing delay, how much time does it take if you want to buy a new ticket, how long you have to wait in the queue, or how long you have to wait on the platform to get inside the train. So how much time you're stationary on the station. So that is further deeper level of information, zoomed in level of information of your activities on the metro station. So in the second step of this problem, we looked at this. Now, in the interest of time, I will not go into the entire detail of how we solve this problem. So let me just directly jump to the point where I tell you about results. So this is, you're moving inside the train station. This is the queue. You stand in the this is where you are sort of stationary before you get on the train, and this is where you climb up down the stairs on a metro station. So classifier directly telling us, this is our result at the end of all the study, to detect which class you are in. So we have to use a hierarchical model, a hierarchy of classifiers. So the first level classifier, will say whether you are climbing stairs or not climbing stairs. And that we can do at a very high level of accuracy. Now, when you are not climbing stairs, that means you are on a plain surface. you could be either moving or not moving. Okay, so we employ a different classifier at this level, not moving. And if you are not moving, that means you could be either stationary, standing still at a point, or right queuing. That means you are moving but intermittently. So when we use a flat classifier to detect all these green classes, it's not so accurate. But if we go step by step, like a waterfall or a decision tree, then we got far better accuracy to detect whether you are stationary and queuing. And stationary and queuing is something that is the very high estimator or indication that there is a lot of rush in the metro station. Yeah, so we did all that study, and for different levels, we tell you now which classifier works out to be the best ones. Overall, the accuracies that we see is 75%, and the F-score is 0.74. At this point, the smaller window size of 20 seconds worked out to be better one. Okay, in the first part of study, right, window size of 40 the best. But when you are right looking at a very fine movement of stationary, walking, queuing, then the window size of 20 worked out to be better one. Okay, so the flat model did not work out. We have to use multiple classifiers, one after another, to detect. So the flat model was just giving us 58% of accuracy with the F-score of 0.55. So that's where we stand. So now let me conclude and then summarize. We were able to now get using just a smartphone and the sensor that your smartphone has got, we could tell you whether you are traveling in the train or you're waiting at the metro, for your weight on the queuing, standing in the queue, or stationary, or climbing up the stairs or not. And this could be done with any smartphone that you have, which comes with the standard off-the-shelf sensors. Now, this is giving you an idea about the smart cities, and we could leverage the similar things even for taxi routes and bus stations and different sort of railway stations platforms. And the sensors are very simple. The time series data is right. We already have that coming in from different phones. We just have to use the right smart techniques of machine learning and AI to give us higher order smartness or analytics of how people are moving. And this could be done for city planning, for planning environmental pollution, and to handle, reduce the pollution. For healthcare, there are many applications, because if you can tell whether the person is climbing up or not, and so on, how he's traveling or she's traveling, that data can also be used by the doctors to understand the movement of the person. And then even for the buildings, to make it smarter, how people move across the buildings, how mobile they are. So even the buildings can get smarter. So overall, we come at the point where we can bring smartness to the cities and our environment by using simple mobile phones. So that's all I have.
Yeah, so there is a question from Subham Agrawal. He is asking the routing problem that requires us to find
Sanjay,
the
back
shortest.
to you.
Yeah. So thank you. So this, I am reading a question from a student.
Okay.
Subham Agrawal. He is asking the routing problem that requires us to find the shortest path between some source and destination were being solved by various genetic algorithms. So the algorithms that are being used by Google Map and other major platforms still inspired by such genetic algorithms.
Correct.
So what you want to ask? He didn't pose the question. His statement is why he wrote the statement.
Correct. Yeah. So okay, but I sort of see what he wants to say. He's saying that for routing algorithms, yes, how to find the shortest path is a question that we want to solve on Google Maps, let's say. But the other question is, you may not always want to reach your destination in the least amount of time. I could be a person, I can wait. I don't want to reach the earliest, but what I care about is I don't want to go into a rush or a crowd where it is all congested. Okay, so if my optimization is a different thing, not the time, but the rush, then I need some data so that the weights of the different paths on the route or on the map can get an estimate. The weight is an estimate of the rush. Now, what problem I am solving or we are solving as part of this work is this giving those weights to Google so any routing algorithm, it could be genetic, it could be shortest path, Dijkstra, can now use those weights to give me the path with other comments, questions. I hope.
Uh, I have one question.
Yes.
I just attend the entire thing. So one thing is that whenever you build a model, so is there any possibilities to measure the correctness of those type of the model?
Yes.
So
So we collected the ground truth. That means we had also a diary which talked about visually seeing how much is the rush, because these participants were carrying phones and the data that our algorithms needed was collected automatically.
okay,
But overall, the people could see, the participants could see how much is the rush at that point, and they maintained that diary. So at the end, when our algorithm evaluated these things, we also corroborated, right? We confirmed this with the participants that this is what we found, right? You spend more time. Was there rush? Yes, and we found that that matches. But there are exceptional cases. For example, right, the algorithm can be sort of fooled if you carry your phone and sort of wait in a queue, but don't buy tickets. You just you're loitering. You're just moving around in the metro platform. Now that would indicate for us that there is rush, but there is actually no rush.
okay.
So there are adversary models which could derail the algorithm, accuracy of this algorithm. In that case, we have to depend on people, that there are many people, and we will then look at many people's data at one location, and then we'll only say, not just by looking at one person's phone, we look at many people's phone and then say something. Assumption is that many people are not adversaries.
Oh, well,
So I think, yeah.
So in this case, I think if we model the entire systems using some well-known software engineering model, for example, the features model, in that case, we will put this module as a human in loop. Am I right? So
Human in the loop.
yeah, so in the entire system, so human is in the loop. So from their data, uh, algorithms can run and takes the actions necessarily.
Um, I think for the evaluation purpose, you can put human in the loop.
Okay. Okay.
But for the purpose of collecting of data, we would want this system to be totally autonomous,
Okay.
because that's otherwise it becomes too much of load on the person to continuously give feed.
Okay. 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 Got it. Got it. Got it.
Yeah.
Thank you. Thank you.
Okay, so let us thanks Professor Naik to deliver such a innovative talk, which give the latest information how you can use the machine learning for understanding the rush or crowd in a certain place. So, okay, thank you, Professor
Thank
Naik.
you. Yeah.
Thank
Thank
you.
you. Bye.
Rakshit, that Divyasheel arrived.
Yes, sir. Divyasheel, sir. Good morning, sir.
Yeah, hello. Hi, Rakshit.
Hello, Divyasheel. This is Sanjay Sahay.
Yeah, hi, Sanjay. Can you hear me?
Yeah, I can hear you. So, can you share
Okay,
your slide?
sure. Yes, please.
Okay, so
Give me a second.
our third speaker today is Divyasheel Sharma. He will talk about the startup in CPS, and his
No,
talk ML4, acha,
yeah.
machine learning for CPS, and industrial automotive view. So Divyasheel Sharma is a senior principal scientist at ABB Corporate Research in Bangalore, India. He has received the PhD degree in 2010 from the School of Computing and Information, University of Pittsburgh, USA. For his PhD, he worked on efficient information access in data-intensive sensor network, where he developed a data transmission algebra and a decentralized reinforcement learning-based adaptive approach to deliver data. In 2010, he joined ABB Corporate Research, Bangalore, where he has been building a industrial machine learning system. So, this Divyasheel Sharma, I think your talk is very interesting. It may be interest me also, because you are talking about decentralized reinforcement learning based adaptive approach. Wow, that's great. So, welcome Divyasheel Sharma, and please proceed.
Sure, Sanjay. So sorry to disappoint you. I will not talk about
Okay,
the decentralized reinforcement learning today.
okay,
That was part
not
of my
issue.
thesis work,
Okay, okay,
but maybe another time we can have a discussion.
okay, okay.
Uh, so today, I believe I have around 30 minutes, right? So uh, I will be talking about machine learning for industrial cyber physical systems. And I will specifically give the industrial automation view, and I will also set up the context for that, what it means. So, okay, I'm unable to move my slides. Do I need some permissions?
It's okay. The slide is visible, you are visible, audio
No,
is
no,
coming,
I was unable
full
to.
screen. Full screen. Achha, now it's full screen.
Uh, yeah, I was unable to move slide by
Okay.
slide.
Now it
So,
is moving.
sure, yes. So, so today's talk is in two parts. So first, I will set up the context for what I mean by machine learning for industrial cyber physical systems, and essentially, I would like to highlight what industrial automation really means here, and how machine learning is being adopted in the second part of the talk. So. Uh, to highlight, where I work and how it's relevant. So ABB is an industrial innovator for last 130 years, and it's a Swiss-Swedish company, and it has been there from right from the Industrial Revolution, participating as well as really inventing various types of systems. So in 1889 or so, ABB developed third phase systems for for generators, etc. And it has continued to develop innovations in locomotives. Then in in the Industrial Revolution, there are numerous contributions starting from one of the earliest industrial robots, as well as the extended automation system, which I will briefly touch upon as well in this presentation. And latest, ABB is playing a central role in digitalization digitalization of the industry. Also in electric vehicle charging, it is innovating and is one of the prime runners. We also are we sponsor Formula E, where which is also serves as a test bed for electric vehicles. So it has a rich history of innovations. And just to give the scale of the problems that get solved, so world's largest paper mill in Sweden, or world's largest container ship, or world largest chemical complex. All these are automated and managed by ABB. So essentially, ABB's control system manages all these big plant systems. So, what does it mean by automation and controlling such plants? So we all understand that automation essentially is that if there is some process or procedure that is being performed, if it can be performed without human assistance, that is automation. Now, we do not believe that everything, that humans should not be part of any of the industrial systems, but we actually believe that humans should be augmented by technology in such a way that they can take advantage of all the technology to perform lots of mundane to even quite intelligent tasks, but humans do remain as part of the complete system, where their experience keeps keeps providing insights which could lead to next level of innovations. There are obviously there are places where definitely technology has taken over the jobs which humans were doing. However, humans have then moved to do another higher level of job where their faculties could be better utilized. So the challenge that really comes by manual work is that it doesn't scale, and in order to scale it properly with consistent quality and productivity, automation plays a big role, and this is where automation systems come in. So ABB has this 800XA automation system, for example, as one of the automation systems, and it has huge installed base. And as you can see from the picture also, it manages big industrial plants. So if it's a chemical plant, then all the processes of this plant are managed by the control system, which then helps in improvement in productivity and the yield and maintaining the quality of the product. Now, to get into more towards the cyber physical system context, let me highlight that what is the structure of such automation system. So although you can't see the picture very clearly, but at the bottom on the right on the picture, this level 1 is essentially where sensors which are sensing, let's say, industrial environment, which may be on top of devices like motors, etc. And the devices themselves, all these lie on this level 1. And then the controllers, which understand based on the data that is coming and the logic that they have, what needs to be done for a process to work properly, and all sorts of intelligence could be built in here. So controllers are the second layer, and then the third is supervision, where so part of the second layer itself is also supervision, where humans come in play, and they are monitoring the complete situation that is happening and also intervening to make sure that the operations are safe, the quality of the products are maintained, and the yield is also good from any of the industry plants. And then there are level 3 and level 4 in the automation system architecture, where it's about the data that comes from here is is not only stored but also more intelligence could be derived at a plant level, and could be also utilized along with the other systems that are present in plants, for example, enterprise resource planning systems or quality systems. So to give an example, if it is, say, a pulp and paper plant, then the control system may be, so control system will be monitoring the paper process, paper and pulp to paper process. On the other hand, all the quality related things, data, quality of the pulp, etc., would be, for example, in a quality database or a enterprise resource planning database. So this is the automation system structure, which you can see that goes from very low level, right from the sensors to at the highest level, keeping all sorts of information, whether it is related to the a process that is running or the raw materials that may be part of it. So everything comes together in such a system. Now, I would like to highlight that from 2013 onwards, we started to talk about Internet of Things. ABB, in that sense, has always been, a company where these things have been really important, and we have always, networked these. And in 80s, ABB created this extended automation system, which is widely used by all over the world. As I showed before, there are 130,000, more than 130,000 installations there. So this network of things was already there from 1980s, and then recently in from early 2000, we also have been working on connecting the automation system to cloud. And the motivation behind that has been, of course, all the cloud related motivations behind processing becoming cheaper, etc., and the scale that can come from there. But also, if you see on the right hand side, then rather than monitoring one plant, if I'm a big conglomerate, I can now monitor all my plants, and I can do all sorts of global analysis that otherwise would not have been possible. To just give you one example, if there is one batch which produced a fantastic quality of product, then if I would like to replicate that across all other plants, then I need to be able to access all the data from all the plants and understand why really one plant has been able to create a golden batch and what is really not working out in other plants. So these kind of global analytics also start to become possible. So, and this is the industrial IoT in that sense, which also we have been working on from early 2000. Now, now we have ABB Ability as ABB's platform for getting all the data from plants to cloud, and also provide remote operations related solutions there. So, but it just doesn't end there, and this is where the connection comes clearly, that how this is a how what we have been doing throughout is what is being talked about in IoT or cyber physical systems, is that we have all these together with compute that is available in cloud, along with centralized management of for example data, and various services that we can offer to customers through cloud, which could scale throughout the world. We also have these devices, and we also have humans in the loop. So in this is the right cyber physical system in industry, and all sorts of innovations that are happening in academics are applicable here, and we follow them to see the application. Now, this is where I now switch to the machine learning part, and so till now what we really saw is that how an industrial ecosystem of plants is actually a cyber physical system, and industrial automation, where we want to do this intelligent task of managing end to end, let's say whether it's a chemical process or whether this is oil and gas or any other energy sector, or there are ships which need to be managed, complete, not just one ship, maybe fleets of ships need to be managed. So all sorts of industrial devices to industrial processes could be managed. So this becomes a part of the industrial automation area, for which I'm now going to talk about what is the role of machine learning there, and how companies like ours are adopting these. So the main goal for most of the companies, most of the industries in this fourth industrial revolution is really to start to move from automation towards autonomy. And here, what is important to understand is that full-scale autonomy is not necessarily possible today. Apart from, there are certain situations where it becomes very important. So, for example, if there are nuclear plants, then because of safety, then completely autonomous systems are of definite interest. But as I mentioned before, there are so many situations where humans play a great role, and we want them to be part of it. So even if the goal is to go from automation to autonomous plants, uh, we keep humans in the loop there. Now, to look at from the automation system architecture also, there are these three levels which I have abstracted. So there is cloud, and if you see at the cloud level, the main goal is to be able to provide remote operations. So if you are a fleet of ships, then centralized intelligence to optimize whether it is routes that need to be optimized to then to save fuel costs, or whether it is about really maintenance of the ships that need to be scheduled and planned in a way that while the ship itself is in the sea, uh, when it will harbor, all the things which are related to the maintenance are available. So, and I'm just highlighting a couple of examples here. I already highlighted few which are more towards understanding that if there are 23 chemical plants all over the world, then I want to understand that how different plants are producing the same product, and how the efficiencies could be brought all over. So machine learning, of course, is playing algorithmically a great role here. Uh, Secondly, at the plant level, we want to assist the operator to run the plant. Now, in European or in Western world, uh, it is found that the plant operators are actually, because of the general trends, demographic trends, the plant operators are aging, and there are less number of experienced plant operators available uh, to run the plant. Now, in that case also, automation becomes very important, but the experience that these operators have is it cannot be just transferred to a young novice operator. So machine learning plays a huge role now, currently, uh, to be able to support a novice operator with the intelligence that the expert operators may have. So there's a lot of work here, and I will touch upon a couple of use cases there. Secondly, as you can understand, that if an operator or a few operators are running a big plant, which means if it's a chemical plant, then various processes, then it is very important to have a situational and contextual awareness, because it is important to run all these plants safely, but also look for any optimizations that can happen to improve the yield. And there are number of decisions that these operators have to take. Imagine that an event happened in the plant, which shows on a monitor as a in a process trend, which you can correlate with, for example, an anomaly. Now, what are the actions that an operator have to really take? So again, machine learning plays the role in identifying such events, as well as in trying to sift through the data that may be available in the plant, both from the process data, which is related to time series, as well as the text related data. For example, every shift operator writes an operator note after they are done with the operation for their shift. They also write maintenance notes, etc. So all these become important. And then, of course, because so much of data is available, and the operator would really benefit from that data being mined. So that is another role that machine learning plays here. Thirdly, at the edge, now one of the things that is important for many customers is that they do not necessarily want to participate in the cloud strategy. They want their data to be within their plans. And secondly, there are privacy related concerns. You know about regulations like GDPR. I mean, guidelines like GDPR are there, and pretty much coming up all over the world. And lastly, sometimes it is just not cost effective to have cloud based solutions. So in these scenarios also, for real time analytics to provide intelligence, it is important that machine learning algorithms are can be all the inference can be done in strict time guarantees uh, on such edge devices. So you can see here, if you draw parallel to what is happening in outside industrial world, in machine learning, everything is very much applicable in this setting. Now, we all know that machine learning runs on data, and at times in academics, we assume the data is available. But I'm sure that everyone will appreciate that that is one of the biggest challenges. And especially if you work with an industrial company on a project, you will see that that is one of the big challenge. So there are huge initiatives that we have undertaken, and pretty much all of the industry have undertaken to first collect data. And now there are various scenarios with miniaturization of sensors and cost reduction there, with the ability with cloud becoming cheaper. So there are various things that collecting data and is relatively cheaper. Uh, uh, Also, with machine learning coming in play, people are now willing to pay the cost associated with the data to so essentially whole of the industry is moving from volume based to value based offerings, and value machine learning is one of the biggest components there as well. So since we know that machine learning runs on data, and so in one of the projects we looked at that whether it makes sense to always send data to cloud, or there are situations where we should actually try to go to the data and do the analysis. So there are numerous scenarios, it turns out, where this becomes important. You can imagine a large area network of windmills, which is called a wind farm. And if each of these wind farms, so they have turbines, right? And if these turbines would need to be monitored, or even for analysis that may need to happen there, does it really make sense to send all the data all the time to cloud, which is also expensive? So in such scenarios, and there are numerous such scenarios, whether it makes sense for ships to send all the data to cloud, whether it makes sense for oil wells, to send data to cloud using satellite communication and everything. So various use cases are there. So what we did, one of the things that we have done is we created this databases which could be right there in, for example, turbines embedded there. And then this becomes like a problem of network of databases where query becomes the first class citizen, not just the data. And rather than sending all the data to the cloud, one could actually query for the right data. Now, you may know the destination, you may know what you're looking for, or you may not. But uh, but you could issue the query, and which could then provide you filtered results. Now, not only that, we may want to do predictions there. So we may want to predict a turbine fault and look for that. So if you can imagine, for example, a sequence of data. So and if you were to, let's say, run hidden Markov model. So essentially, you are trying to do is calculating probabilities there, right? So you could actually, if you think about it, you could write a query which could do such calculations right there in the embedded databases that might be there. So we created this network querying service. So here it is both the system as well as the machine learning which need to be developed. And I understand that I'm running out of time, so I'll go a little bit faster. So and there are various cases where this is of importance, and I've tried to highlight some of these here. And I already spoke about, for example, monitoring the health of the ships, or whether we want to do this golden batch replication related problem. So this is an important way to think about that. We could actually send query to do the machine learning, right? I mean, do the inference right on the device, but we need to set up such infrastructure then. On the other hand, if we come to the humans or operators there, uh, the motivation is that we want to help them to drive operator excellence. And here one could so there is huge amounts of plant data which so imagine any plant, right? So 24 by 7 there is data which is being generated by machines, by also the process. So can we mine this data? And there are then various scenarios. This data is of really large scale. How can we really utilize efficient methods to mine data, to, for example, search through all the historical data maybe for last 10 years and find out if a particular event has happened before or not. So we utilize various time series algorithms, state of art time series algorithms, along with data mining algorithms, as well as deep learning methods to evaluate there. I can give hints about some of these algorithms. For example, matrix profile algorithms are there. And then there is associated text data also, which now with all the leaps that natural language processing has taken, we are able to find contextual information from historical data. On the other hand, we talk about digital twins, where we can simulate the complete processes and then build surrogate models. And this is happening not just in process plants, scenarios where complete data centers are also tackled in this way by creating surrogate models. Or you can think about like turbochargers, where you are trying to say optimize the design. Similarly, at the edge, I have motivated already that inference is important. And this is something which is a rapidly emerging area where we are also looking at different techniques that we could do at least inference at the edge for now, and maybe training also in future. So here, this is more from academics. We have done experiments here, but we find that these techniques, especially when pruning and quantization come together, are very helpful in reducing the size of the otherwise pre-trained models from anywhere between 10 times to 30 times. So I would like to end this brief talk by highlighting on some of the model-related challenges that we are working on. One of the biggest challenges to be able to deploy the models at scale. You can imagine that the firmware that are there installed in the industrial devices may be from decades earlier, and these firmwares may be in each installation maybe have different variables which are recording data. So how really to scale whatever model that you build, what would be the smallest subset of the data that you take and still deliver a model at scale. Of course, there are other challenges which are related to deployment, but I would like to highlight these. Then stakeholders, especially in industrial settings, where uh, indeterministic algorithm can provide certain inference which can actually lead to disaster. Then how so these interpretability and explainability approaches are also very important. And in the end, how humans, considering the worker economy, how humans could still be part of it and leverage the technology rather than be consumed by the technology. So there are various challenges that we are working on to address and bring productivity. So that's where, on this note, I would end the this brief talk, which gives a flavor of at least what is happening, what are the current trends in the industrial cyber physical systems from machine learning point of view. And I'm happy to take comments and questions.
Thank you, Divyasheel, to let us know that how EV is playing an important role in automation of industry. It's very interesting. But let us take the first two quick questions. One is from Rakshit. Are these sensors being developed by ABB in-house or that job is outsourced?
In-house sensors. So yes, these are in-house sensors, and there are also various kinds of challenges actually happen. You can imagine a big plant with say 20,000 motors. Now, even if you put a smart sensor there, all the data that it senses, it's not going to be easy to send this data to any edge or cloud to do all the processing. So what ABB does is that the smart sensors are actually able to do enough at the edge calculations that only the requisite data gets transferred, or the intelligence is built right in the sensor itself, which is latest innovation. So smart sensor is the latest innovation from ABB for various, for example, motors, etc. So these are inbuilt. And the other challenge with these is that these need to be licensed. One needs to get safety license for all these before these can really come into industry. So the overall cycle is like couple of years. So a lot of innovation, multi-year innovation goes in these sensors when they come out. So this is an in-house job for ABB.
The next question from Pramodip. He is asking, do you look into any validation related issue to prove the correctness of the systems?
So absolutely. So not I think you're talking from machine learning point of view, that whether the predictions that are coming out from the machine learning models, whether those are correct or not. So we are working on the assurance frameworks also, where we start to. So of course we do everything that gets done on training and validation of models, but it doesn't stop there. Once the models go into deployment, then the production systems, at that time anything can happen. So it is a constant monitoring of the input data to make sure that there are no drifts in the distribution of the data happens as the very first point. And then secondly, there are few innovations which are for example, if you have to think about it, you can build generic deep learning models which can tell you whether there are deviations in the distribution of the data. So at least this is monitoring which preempts the uh, uh, the customer where the models are deployed, to understand what is happening. On the other hand, what might happen, so that they can take corrective action. On the other hand, we actively look into the explainability of the models as well, so that the humans who are the experienced operators should be able to understand whether what model is saying, whether it makes sense or not. It has to correlate with the human intelligence as well. uh, and there is a risk of automation bias there, but currently it is actually more of a feedback that comes from the human to understand whether the model is valid or not.
Okay, so this last question that what Bhavya is asking, what is the extent to which machine learning operates at plant level? Does it recommend a novice worker in a plant with a particular set of action, or does the appropriate steps more automatically with just monitoring required?
So both the things, I'll give examples. So uh, if for example, if there's a safety situation, then machine learning can actually recommend. How can it recommend? Because there are manuals and there is work that people there are actions that people have taken historically in a plant, right, in various situations. So you mine that data and you can recommend uh, what is the workflow of next steps given a certain situation that has occurred in the plant. So that is one where it is more automated. but this is where you understand the event better. The other part of this is where you do analysis like what if or do why, right? Where it is more towards either causality or towards prediction in future. So to give a concrete example, operators change set points for processes, by which I mean that if a process is running, let's say one of the devices there is running at certain RPM, right? Let's just say that it is running at 1200. Now, or if the set point correlated to that is, let's say, 12, and you want to change it to 24. Now, with your experience, if you are an experienced operator, you may know that, okay, if I change within the range between 20 to 24 in certain situations, then the process becomes yield becomes better. However, if you're a novice operator, then you may not have that knowledge. So that is where the digital twins, which people talk about, or high fidelity simulators for the process help, where we create huge amount of data, and we also try to utilize the physical models that may be behind, which may be also be available, correlate both of these, build surrogate models. So you can imagine, if it is data driven, you could build, for example, an LSTM model, which could then predict that for a novice operator, it could shift to the simulator and say, which is a surrogate model, and say that what happens if I change the set point to 24 now, and within seconds, this digital twin based simulator or high fidelity simulator based simulator, a surrogate model, will predict that what might happen, and that gives more confidence, or warns the novice operator either to take that action or not take that action.
Yeah, in this question, there's one small sub questions.
Yes, please.
You may have okay, what is asking that you have any number how the cyber physical system have increased the efficiency from the traditional work number
Right.
quantitatively. Yeah, I know it's a dramatically increased, but somebody asked you may have any number.
Uh, Unfortunately, I don't have a number, but I'll try to give you an impact metric. You just imagine a simple, let's say, okay, let's take a very simple example that we live in communities and there are CCTVs, and security staff monitors everything by just manually looking at the screen, that if there is something happening or not. Now replace that by a vision based model, right? Once that model runs, you can see that what is the impact. Now, on the same, I would like you to draw the parallels. I can't give any numbers, but I can, help you that draw the parallel in an industrial setting. That what kind of efficiencies are being looked into, and it is not just that the old processes are improving. It's also that some things which were, earlier not even I mean, which were just blind spots, those now could be covered as well. So some things which otherwise could not have been monitored and could not have been analyzed are also possible. So the reason the impact is going to be large could be also gauged from the investments that pretty much each company in the world, each industry in the world has a budget for machine learning, or hiring data scientists and building and digitalization. So that can also be gauged from there, that what is the impact that is being perceived. Whether the impact is current, that is a more valid question. And currently there is huge investment, and as essentially, especially as deep learning models, they have started to perform better and better, and as explainability and assurance techniques have started to become better, more and more more and more adoption of machine learning will come, even in slightly more critical areas. In completely critical areas, currently machine learning is not necessarily going to play a role. To give an example there, so if you were to use a reinforcement learning model to, let's say, control a plant, that's not going to happen currently. Currently, what might happen is that the error that a controller may have reinforcement learning may actually try to reduce that error further. So that may happen. So that's the state where we are. But unfortunately, I don't have concrete numbers to give you.
Okay.
But it's called next industrial revolution for a reason. That it is.
Thank you, Divyasheel. Beginning of time, I have also questions on you about criticality and applicability of deep learning that I will talk to you offline, because that is also very important. And thank you for the informing all the important contribution by the ABB on the automation of industry. Thank you once again.
Sure. Thank you so much.
So now, Rakshit, can you go to the next session? What is that? Rakshit. Rakshit, can you hear me?
Yes, sir. So next we are going to have this panel discussion on.
So you will take over.
Yes, sir. I'll share this session, and the panel discussion. The topic for the panel discussion is encouragement and importance of undergraduate research, and we will be hosting professors from BITS Pilani Goa campus. We have Professor Soumyadeep Bandyopadhyay from the Department of CSIS. We have Professor Neena Govias also from the Department of CSIS. And we have Professor Reena Charuwala, who is from the Department of Humanities and Social Sciences of BITS Pilani Goa campus. So I welcome you all. Good morning. Thank you for joining us here for this panel discussion. Neena ma'am is also the Associate Dean for the AUGSD, which is the Undergraduate Academic Division. So ma'am plays an important role in the in undergraduate affairs for all students. So without further ado, I would like to request the panelists to make their initial. Yeah, Soumyadeep sir, would you like your initial word for panel? We can't hear you, sir.
Hello, am I audible now?
Yes, sir.
Yeah, so can you please repeat your questions, because
So, sir, the topic we have for us today is encouragement and importance of undergraduate research. And we know how BITS is now striving towards increasing its research footprint. And we are also looking to, because research BITS, ultimately we want to be a core research university, which we are striving towards, and which various plans have been associated. We have this whole BioCPS grant which we've just gotten, and a big chunk of BITS and BITS Pilani is its undergraduate students. They are like the most numerous. So obviously, the next forefront for BITS will be pushing undergraduate students towards research. So, what comments would you like to share on this?
Well, Rakshit, one of the important point is here the importance of the research. So the importance of the research is very well known. So nowadays, if you see the ranking, the NIRF ranking or the CS ranking, they only concentrate in the on at about the 90% cases is the research oriented stuffs. If you have a good publications, good projects, so your research value will be increased rapidly. And the honestly speaking, I'm a member of the computer science. Being a part of the computer science, I've seen that is uh, the very few persons, obviously compared to the science background, the very few persons are going to the research because there is a industry jobs are there. They and the student will get the lucrative salary. So if the research fellowship will not hike, so then the students will not be fascinated to do research. So to do that, what I my point it is that in undergraduate course there is a lots of projects curriculums are there. So if we
No,
put,
but Samadhi, how undergraduate will get the fellowship?
no, I'm not taking, I'm not giving the undergraduate fellowship. In the PhD programs, there are
Okay.
some fellowships, and only the president, apart from the president fellowships, the maximum fellowships are, is this, but not comparable with the industry fellowships. The not I'm wrong, because not comparable with the industry salary, not the fellowship. So that's why the people's passed from the undergrads and they motivate to join to the industry. But one question is very clear. So why they are going to the abroad? The first and foremost is basically there is some charger of peoples and there are some pipeline problems out there. There are some good groups out there, and whenever they will go abroad, actually they will get the salary. For example, the 12,000 euro. So if you convert it to the Indian currency, that gives some huge amount. So that's also the lucrative for the students perspective. So generally the people are doing their, so 2 years jobs or the 3 year jobs, they will collect some money and went for the abroad and do the PhD program. So that is basically the traditions. So now so the according to Rakshit questions is the research is important and the innovative mind should also come from the undergraduate studies, because in BITS, at least in the premier institute, just like the BITS and the IITs, CMI, Math Science, this sort of institute, so there the brilliant people have comes over here to do study. So if we ignite them to make some innovative mind, to do some the current scenario, what's the problems that people like to solving, and which is obviously related to some industry specific problems. So the students will be more enthusiastic. And
I'll just interrupt you here, sir. I would like to put the ball in Nina ma'am's court because ma'am is associated with like planning academics and especially for undergraduate students. And we do have project courses which do stimulate the research activity for undergraduate students. But are there any other steps which we can take, ma'am, or which the administration is considering to bolster research for undergraduate students further?
No, BITS has traditionally always believed in flexibilities to be offered to students. So, of course, project courses, we even have internships which are being formally done nowadays. But the problem is there is a matter of choice in the sense that undergraduate student usually has some ideas that they want to work on. It's not like, you give them any opportunity, they will come and work with you. It's unlikely that that happens.
Exactly.
Now the problem is the latest trends or whatever is usually what a student sort of picks up and comes and says, I want to work in blockchain, I want to work in some particular topic. And now what happens is usually the faculty concerned are one step behind in the sense that they still haven't picked up those trends or they don't think it is relevant to their research. In which case there is a mismatch between what the student usually wants to do and what the faculty can offer. Now, at least in the topics which have just come up, data science and AIs and things like that, there is a possibility that whatever the student wants to do can actually be fruitfully employed in the research which the faculty is currently doing. It's just a matter of what shall I say, sitting down and finding out which are the problems which can be solved with such approaches and offering it to the student in a nice package. I mean, I'm sure in most disciplines there is data. Like I had a few days back seen some biological data which one PhD student was supposed to be, had gathered. It was not analyzed at all. So when I looked at it, it looked like, maybe, I should, match them with some student who is interested in doing that kind of work. But the problem is that data usually is, what shall I say, related to that whoever is the PhD student who was presenting and their whatever. I'm not sure what intellectual property or whatever. and it may not be openly available for others to look at it, because that data had some value for a longer term for that student. So what I believe would help is some kind of forum where multidisciplinary faculty interaction occurs. It is usually like, if you look at computational side, we have lots of students, bright students, who are interested in doing this kind of work, but they need to be given it in a nicer package. If I tell them to go to this chemistry person and talk, they would have this barrier which says, I don't want to deal with chemistry.
Ma'am, and at the same time, can we look at some sort of incentives? Because we know that students who do want to go not into research but into an industrial job, they have huge incentives, salary, like how Samvidhi sir mentioned, and whatnot.
I believe that, of course, money as an ultimate goal is good.
Yeah.
But I think most of our students are not that worried about immediate money, in the sense that the money that they get in the next year or the year after that. They would very much like to pursue something which is, what shall I say, meaningful. So there are two types of students. One kind who want to do something meaningful right now so that it will help them in the future. So in the sense, they would be willing to do finance courses and things like that, because they ultimately intend to do a MBA finance or something like that. That is one trend, which is good. Like, so they go after all the finance courses, they will do finance projects, they will do all kinds of, and all this is encouraged by BITS. But there's another set of students who say, no, let me go to the industry, get experience for 2 years, but I intend to do a master's anyway afterwards. Now, this set of student needs recommendations maybe 2 years after they have joined the jobs. And they know very well that getting it from the industry doesn't make sense. It makes more sense to get it from the faculty whom they have worked with. Now, these are the students who typically do come to us, do work with us, and they like to do something which will lead to publications. Now, that is another, what shall I say, a bit of a problem area, because a publication usually doesn't come unless you work for about a year minimum. Or there's already an ongoing project in which you contribute and you're one of the authors of it. And so all this requires to be packaged in a nicer manner. And typically when a student comes and says, I have done machine learning, I have done data science, I can do this for you, I will not have anything ready to hand over to the student. And it's like, I lose that opportunity. The student probably doesn't match with whatever I can offer. So,
yes, ma'am, I completely agree with you. And this is where I believe humanities and social sciences, the department could in fact play an important role as well, because with humanities and social sciences, those courses, we are dealing with certain subjects which, they can help students be better acclimatized with how to think differently, and how to have certain aspirations in life which may not be align with what the general, what majority of the population looks up to. So I think that is where the humanities department can also play a big role. At BITS we do have a compulsory course under the humanities department, which is technical report writing. And after doing it, and now when I'm writing papers, I do realize how important that subject actually was, because at that point of time, I had no idea that I could actually, that it could be this useful. But at the same time, like you said, packaging it in a nicer and better way so that students understand the value and try to implement it will certainly be very useful and better. So, Reena ma'am, would you like to share any comments?
Can you hear me?
Yes, ma'am.
So from the discussions, what I have understood, that there is an issue related to matching the research interest of faculty and the student. Apart from that, actually, if you see that when the student comes to campus, if you take our system, how much our education system and socio-cultural system support them or facilitate this research. Because when the student comes, they are mainly interested in getting good grades. So it's like we have relative grading system. So they are actually competing with their peers for grades. So it's like my success is your failure. So that in such an environment, such an unhealthy competing environment, I should say unhealthy, how the student will collaborate with their peers for research. And also like peer pressure and parental pressure for this grading means this, of course, if they want to get a good job, that's true. Because 2 days back, one of my faculty colleagues told me that now with this online system, so they are all are at home. So after the exam, parents pressures so much they cannot tolerate them. They were telling that one fellow got 13 out of 15. So the parent is asking, where are the two? And how much your friends got? So see that much pressure they are getting. So I don't know where we can fix that research. So, and what I suggest that it's kind see, if you see all the stakeholders in the system have certain responsibilities, like parents, peers and the management and the students themselves. They have to collaboratively work to provide this research environment, otherwise it will not work. And now we have SOP, like a study oriented project that you have mentioned, that course. But I have seen that students, there are exceptional cases of course, but students take that course to get easy grade. It is easy for them to get A or A minus easily because there is no exam in that course. It's very rarely you get as a student with the passion for research. So that again, that is the responsibility of students, because see, when we say talk about research for undergraduates, actually it helps them to understand what are the existing issues in that particular field and to be solved, and what are the issues so far no one has solved, so that they get an opportunity to solve or contribute something to solve it, which are of socially significant or globally significant. So they have to utilize it. Means even our I think our institute provides some scholarship for research. I think Nina ma'am can say that, how much I don't know, but some support is there. That may not be sufficient, but some support is there, and I don't know how many students really take it up with passionate research, or really they wanted to contribute to the field or society apart from their grading, getting good grades.
Yeah, I just would like to one thing I'd like to contradict with Professor Rina, that is obviously the first assertion is the social cultural systems. Due to the social cultural systems, the students are they're always in the competitive mind. But the thing is that whenever these people is going to the research, they are also being in the competitive mind. That, for example, how many publications you have, how in this year, in which journals you have published your work, or which conference in computer science, it is very common that is the people are published commonly in the conference. So which conference is it, Esther or A or B? So the people are crazy with that. So if you go to some research lab, like the one of the host for this seminar, there's a Telecom Paris, the people are also be crazy. That is we have to do some publications. And whenever I was in the Hasselplatter Institute, the people are doing also the publications also. And in Europe, compared to the America or the Singapore, I can tell Europe is more flexible. If you go to the Singapore or the US, if you see that the universities, so this month there is a 3 deadline. If we miss one deadline, for example, a CAV, we will send it to the, for example, the ADVA or the VMK using this manner. So this sort of situations is going on in research also. But one thing is that at least in the research community, one and only things is there till now, that is the honesty. Because the people are not the blindly copying the materials from some other author's paper. And this transparency is very clear in the research community, that I can say.
Professor Nina, I would like some comments from you regarding what Professor Rina stated about how projects have, like especially SOPs and DOPs and LOPs, how they have just like somewhat become sort of an easy grade for students. And how
Yeah.
do you regulate that?
It is slightly easier to get grades in it, in the sense that you would not typically give any grade below
Hmm.
maybe to any student. So you know you're going to be in that bracket. But I feel that having that opportunity is a big deal, because the ratio of the students and the faculty, at at least in the engineering departments, is quite, I mean, it's like there are very few projects available. And the ones who actually get the project do appreciate that opportunity. And I'm positive that it's not taken into, I mean, it's not taken very lightly, because they know that, you get a project, if you do well, you're going to get a project in the semester after that and the semester after that. So at least there are 3 projects guaranteed if you do good work, or at least, I mean, you don't slack off to waste time. That said, of course, I mean, who gets a project? It is not decided by any what should I say, formal means. It is decided by whoever the faculty meets. For example, I know I have 8 slots. Um, Typically, in the previous semester, somewhere somebody would have come and talked to me, or I have some work which I had already assigned, and my slots get filled, and that's it. I don't take any more students. Even if an interesting student comes afterwards, I know my slots are full. So it is an opportunity, and students do recognize that the importance of getting that chance to do work. Of course, it is misused to a certain extent in many departments, but I have seen grades go down as low as D and E and all. So it's not like it's. I mean, the faculty also are very happy to give good grades, but a minimal amount of work gets you a good grade. The second thing Dr. Ina was mentioning is something about funding. So we have these few departments which have these funds allocated for because of their other activities. These funds have come into the department, and they've kept it for student projects. Now this comes under the head of like students are interested in at least in I think triple E, etc. They're interested in making these robotics related things, or they're making some devices. They're making some using these Arduinos and other smaller boards to create something nice. The mechanical department has some money, and I think CS department also has some money. So it is up to the department to decide how to give it. In 1 year, I believe it was done as a project proposals were invited from groups of students, and it was given to that group to particularly do under a faculty mentor. So they had a faculty mentor. They proposed this thing. They got budget about I think 50,000 each for buying some equipment, and they could do some work on it. Unfortunately, what happens is it's a one-off thing, in the sense that you give it to one group and they do something, and it's a mix of students. There would be seniors who leave. It's not sort of handed over.
Yeah.
In the sense that equipment has been bought, 50,000 worth of equipment is quite a lot if you talk about minor electronic devices. Quite a bit of it can be gathered. But I found at least that I tried, because I was a mentor for one of the groups, and I said, okay, I want to hand it over to the next bunch, the juniors. Can you find somebody for me? But somehow the timing and everything became so basically this thing ends right at the end of the semester before the comprehension. By the time it's difficult to catch a new bunch.
Yeah.
But I believe with Sandbox, there was a bit of I mean, in the sense, long-term projects were done. A few of them reached interesting points. So I'm not currently associated, but earlier I was associated with Sandbox, and I found that very enthusiastically people were designing many things. They even made some kind of bots which could do certain activities and all. And that is a good concept. That means all the hardware remains in the sandbox. Whatever the student is given also ideally is supposed to be kept there. And once the student finishes use, you can sort of reuse it for whatever purpose.
Exactly, ma'am. So since that structure has been created, like Sandbox, that administrative structure was created to facilitate development and research, and that is how, like, that is a success story for BITS. In that sense.
I believe there were clubs, etc., which students themselves had set up. I think electronics club.
Yeah.
What I heard from students or whoever were using, I mean, there were students who were part of clubs and Sandbox. So I was telling them I'm asking them what is the difference between the two. In the sense, I thought if you're part of an electronics club in charge of or whatever, you would get all the devices that you want. Why would you want to come to Sandbox where we are, literally making, note of who's issued what, keep it properly, I think so. So he says it's good to have everything available whenever you want it and pick it up from that club. But what happens is then there is no organization over there. Things are kept randomly, and you want something, somebody has broken it, and you don't have sold.
Exactly. It is more informal.
It becomes very informal. That has gone to a very informal extent, and I believe Sandbox we try to keep it reasonably formal. We didn't want it to go anywhere where things get lost and we don't know who has damaged it. We knew that there would be damage, but it's like at least we know who has done it, and sort of we account for things. because some of the instruments that we bought there are pretty expensive, so we thought it should be best to keep it formal. But the departmental grants need to be sort of. It would be nicer if it can be handed over in the sense that juniors work on the project and sort of go ahead. Because I have a bunch of equipment which the senior student had bought, and I was trying to get it to junior people to work on it, but they point blank refused, saying that these are older versions of, and that is additional problem. So if you buy a Raspberry Pi, some version 2, and the version 3 has come, and nobody will touch the older version. It's like no, I cannot use that. Only the wires are useful, is what they told me. So I said, okay, nothing I can do because B plus has come. There is this problem about hardware having going through some. Even software I've seen sometimes hits a barrier of new version.
So Professor Sahay, do you have any comments? We have got varied views from.
Yeah, I can comment only that how to improve the undergraduate research. See, basically this two sides. One is faculty side, one is student side. How both will get benefited. Benefited in the sense that students should learn something, and obviously they come from the grade that what from the discussion comes out. And faculty see that how rigorous student is to focus to research. Some output should come. Faculty focus on output. Obviously, if output come, faculty will give the grade. But the BITS is very flexible, and students should use that flexibility. But some people misuse. See, flexibility like the so project courses after the thesis, it's sequence, right? So initially I think from third year, they can do some project and learn that and then apply in the next semester. But what appears that in the first semester, if you push some update new things, they struggle. And they like that what the standard, they should get grade and all the things. They don't want to focus on the, some few students I see that want to work and they struggle and they come out with good ideas and all the things. But most of the students, they see that I will first hand, I will get the grade or not. Secondary is that some output, and for faculty, output is primary. Grade is obviously they will give how he or she is. Generally, grades of the project is not very low unless it is very, very worst, right? So that the students should understand that you should not go to the faculty with a topic which is not in his boundary or her boundary. You should research properly what faculty is doing, approach him. Obviously, he will interested if it's what he likes. Not you just say, sir, I am interested in doing this. That's a mismatch that what I have seen. Somebody comes, sir, I want to do this. That time may not, earlier I may did that 2-3 years back. But right now I'm not interested. Today I'm interested in something else. So if such thing comes, obviously faculty will interested and he will devote. But if there is a mismatch and we find that after 1 or 2 months, if a student is not sincere, so it goes. And students see that if I don't get the grade, next time I will not come to that faculty, or he, whatever he work, he will go to the other faculty that I have observed. And same thing he will do for the grade. So that has to be some way student has to understand, and faculty also understand that what student looking for, and students understand what faculty looking for. And if that happens, then obviously that research will improve in the undergraduate level.
Yes, sir. So Professor Reena, we also do have SOPs and project courses for the humanities department as well. So I would like to know how do students contribute over there, because the views which we have gotten so far are more limited to I guess they are limited to the engineering and the technical side. So how do students fare in the humanities department and research over there?
Same issue that we also have, that sometimes our interests do not match with whatever they are interested, and very rarely we find that very students are really interested in doing SOP, related to social issues and all. Because my personal experience is that they are interested only mainly because of this. So easy, it is comparatively easy to other courses. Of course, there are students, exceptional cases, that are really interested. And related to this process, Avidev has mentioned issues related to plagiarism and honesty, like copy pasting. those are common in all the courses. It's not only in computer science or HSS. So what I understood that they don't know actually it's very serious offense. Like simply copy pasting, they don't know if you without referencing what is a big issue. So maybe in the beginning itself, if we tell them that these are serious things, you should not copy paste, or whatever the material you are taking, you have to give proper references and all. Maybe that will help. It is.
Yeah, I would like to add one point in the research, that is the networking. The networking, possibly I talked to Professor Shah last couple of days back. That is, the networking is one of the important phenomena which is reside on the research itself, because the standalone basis to solve a problem is a very difficult task. If we share the knowledge and gather the knowledge from some other institute, the other faculty, so it will be very good. So that's why, so the formation of the group where some diverse domain of experts will become into this platform. For example, me and Professor Shah is working, so he's working on the security and I'm working on the formal method. So we just merge these two research area and we try to find out a common research domain, so where we can excel our idea. Similarly, if you see, that is, we are also collaborating with my good collaborator Dominic, who is one of the co-organizers of this seminar. So he is working on the modeling language, and I'm working on the verification. So we just working on the modeling and the verifications of the cyber physical system. So using this manner, if we make a group, it will be enrich the research environment. So the peoples are talking to each other every time. They share the idea and they interact with the students. There are some seminar of the reading groups. So that enrich the research horizons to day to day. Am I right, Shah? Professor Shah?
How you will pass this to the undergraduates? The focus is to that what we are in the faculty level networking. No, that has to pass. That has to pass to undergraduate student.
Exactly. Whatever we will do, that should be passed to the undergrads level. So that's why in the some hierarchies, for example, the one or two faculties will be there, one postdoc, two PhD students, two masters, and lots of undergrad students. So the undergrad students are the workforce of the research activities.
Yes, sir. So we are like almost towards the end of our session. We are actually running 18 minutes late, and we are already into lunch time, which is 1 to 2 p.m. So I will just give my closing comments as the moderator for this panel discussion. Collating all of the views which were shared by our panelists, which is, yes, we agree that undergrads are like a workforce for research, and there are um, there are inconsistencies um, between there has to be a better marriage between what the faculties want in terms of research output from students and what are the aspirations of students in terms of outputs from their projects or research activities which happen. So looking at the past, looking at a past success for BITS Pilani, which has been sandbox, where things were more formalized and the platform was made such that there is more accountability. Maybe we can look at some similar platform which integrates, which presents, which basically integrates student vision and faculty vision at the same time and allows them to collaborate in terms of research topics much better. So maybe something like faculties post on a public domain, on like a community server, they post all of their research projects, and then students discuss them. Because right now, as Professor Nina mentioned, the SOP and DOP, that whole curriculum right now is very informal. So you just go to a professor and you ask them for if they have any projects or not, and then you figure out whether you are interested. So maybe something, maybe a platform which is more formal, and which fosters a research-based, like ideation and discussion of ideas between faculty and students. I think that could play a big role, and that could really do something in terms of undergraduate research and helping out students who are really interested. I really thank all the panelists today, Professor Nina, Professor Reena, Professor Sanjay, Professor Soumyadeep,
Thank you.
for
Thank you,
being
Ritesh.
involved with
Thank
this
you.
panel.
Rakshit.
Okay.
Sorry, Rakshit.
Thank you so much.
Thank you. Thank you. Thank you.
Thank you.
Can leave this session?
Yes, sir.
Yeah.
So all of our viewers, we are now ending session 1 for day 1. We have a lunch break now, and at 2 p.m. we'll be back with session 2, which will be chaired by Professor Nina. And we'll have 2 talks, one by Professor Vinayak Kulkarni and one by Professor Ranjani. So do tune in, and yeah, happy lunch. Goodbye.
Thank you.